evaporative cooler, and moisture condenser with vapor recovery. But first, a comment. Conventional air conditioners, refrigerators, and heat pumps do not magically produce or generate cool air. They simply move heat from where it's not wanted, inside the home or refrigerator, to a place where it's not noticed, outside the home or the kitchen. When heat is removed, cool remains. Imagine we're at the beach. The sun is bright, there's a nice ocean breeze, and the temperature is 72 degrees. Perfect. We go for a swim in the ocean. Everything is good until we step out of the water. Very quickly, we will be shivering with cold, and we will reach for towels to dry off. Why did we suddenly feel so cold? Before it was perfect, and now we are shivering with cold? That question has a two-part answer. As soon as we step out of the water on our skin begins to evaporate, which absorbs heat from our bodies, leaving us cold. And the rate of evaporation is increased by the ocean breeze. This leads to John's law of evaporation. Evaporation requires heat. We can force evaporation by adding heat, but if we allow evaporation without adding heat, the evaporation process itself will absorb ambient or surrounding heat. If we allow evaporation without adding heat, the evaporation process itself will absorb ambient or surrounding heat, leaving cold behind. That's what happens to us at the beach. Think of it this way. Normal body temperature is around 98.6 Fahrenheit, but the temperature of my finger may be a little lower because it is further from my heart. Maybe my fingertip is only 98.0. If I dip my finger in water, pull it out, and measure its temperature, maybe it's 97.5. This is because the water is evaporating, and evaporation requires heat. The evaporation of the water pulls a little heat out of my finger. Now I will blow air on my wet finger. The temperature drops even more because I've accelerated the evaporation. Maybe now it's 95.0. But now I will dip my finger in isopropyl rubbing alcohol, cheap, organic, and biodegradable. I pull my finger out. Alcohol evaporates faster than water. So maybe now if I blow on my finger wet with alcohol, it will drop to 93.0. Here's a summary. We see that blowing on my finger wet with alcohol produces the greatest amount of refrigeration or cooling. So here again is John's law of evaporation. Evaporation requires heat. We can force evaporation by adding heat, but if we allow evaporation without adding heat, the evaporation process itself will absorb ambient or surrounding heat. And I'll add a third point. If we accelerate the rate of evaporation by increasing the airflow, it will cool even faster. That's why clothes on a clothesline dry much faster in a breeze. The more breeze, the better. This leads to air conditioning with no compressor, evaporative cooling with vapor recovery. In 1758, before the American Revolution, American founding father Benjamin Franklin and British chemist and physician John Hadley conducted an experiment demonstrating refrigeration by evaporative cooling in England. This simple experiment, currently overlooked and neglected, will be improved in ways never taught, suggested, or practiced. The invention relies heavily on the work of Franklin and Hadley. That demonstration is well documented, including by Franklin's own account in his own words. Using a mercury thermometer, they measured the temperature of liquid ether in a bowl. It was 65 degrees, room temperature. Then took the thermometer out of the container. Some of the ether clung to the bulb and quickly evaporated, lowering the thermometer temperature by a few degrees. In Benjamin Franklin's own words, the wetting was then repeated by a feather that had been dipped into the ether when the mercury sunk still lower. We continued this operation, one of us wetting the ball and another of the company blowing on it with the bellows to quicken the evaporation, the mercury sinking all the time till it came down to 7, which is 25 degrees below the freezing point when we left off. The temperature dropped to 7 degrees Fahrenheit, a fall of 58 degrees from ambient and 25 degrees below the freezing point of water. You can read Franklin's comments on this here. But we don't need ether. Water will also work, removing body heat, but since it does not evaporate as fast as ether, it will take longer. The experiment may be illustrated like this. They blew air across a thermometer wet with ether, and this lowered the temperature. Please note, they did not use an electric fan or an electromechanical compressor. They had no electricity as we know it. This was in 1758, and it remained for Michael Faraday of England to effectively discover the principles of electric current almost a century later in 1831. What would you do if, right now, wherever you are, presumably inside a building somewhere, air at 7 degrees Fahrenheit started coming from the HVAC duct into your room? That's exactly what this invention does. Below is a small electric fan, a small bowl with a cloth and liquid alcohol, a conduit, the round shiny tube, which looks suspiciously like a dryer vent, and the whole thing is covered and sealed by the white insulated picnic cooler, turned upside down with no top, resting on a flat metal plate. The fan, bowl, cloth moisture pad, and a working fluid, rubbing alcohol, are sealed within the vessel. The fan blows air across the moisture pad, damp with alcohol, accelerating evaporation, absorbing heat, leaving cool air behind. The cool air sinks down to the metal plate, and the warm, alcohol vapor-rich air is blown out the conduit to the right. As the warm, alcohol vapor-rich air continues through the conduit, it gives up or rejects its heat to the cooler air surrounding the conduit, just like a conventional air conditioner. The now cooled air re-enters the picnic cooler from the left side, and the process and the cycle repeat. The whole system is sealed. No alcohol is consumed. Here is the entire sequence. The fan blows air across the liquid alcohol in the bowl, accelerating its evaporation, just like blowing on a cup of hot coffee. This evaporation absorbs heat, leaving cooler air behind in the cooler. The warmed air is forced through the conduit to the area outside the cooler. It's now warmer than ambient, and heat flows from warmer to cooler, so the absorbed heat is rejected to ambience outside the cooler. The cool air within the cooler sinks to the metal plate on which it rests. The cool air from the plate falls to a living space below it. and the process repeats. Thus we see that heat is moved from inside the cooler and rejected outside the cooler through the conduit. The cool air inside the cooler cools the plate and the space below it. This process moves heat from where it's not wanted to where it's not noticed. Here it is installed in a picnic shelter for simplicity, but a house would work the same way. The fan accelerates the evaporation of the alcohol inside the sealed vessel. The evaporation absorbs heat from within the vessel. The heat comes from within the vessel, is forced through the conduit, and is rejected outside under the eaves. This leaves cool air at the bottom of the vessel against the base plate. Now we have cooled the base plate. The cooler air sinks by convection to the picnic area below. As I said at the beginning, the system simply moves heat from where it's not wanted, inside the home, to a place where it's not noticed, outside the home. When heat is removed, cool remains. It does this without a compressor or an environmentally dirty refrigerant. The invention has only three basic elements: a conduit, which may be a vessel, a working fluid, and a fan. The fan may be solar powered. Like a conventional air conditioner, it is completely sealed and consumes no working fluid. This system will be useful for the desalination of seawater, the condensation of dew, and the purification of contaminated water. In all three, the system may cool a condensing plate to well below the dew point. This will accelerate the condensation of salt-free water from the moisture-rich air vapor above a body of seawater. It will accelerate and prolong the condensation of clean water, dew, from moisture-rich air, and would accelerate the condensation of clean water from the moisture-rich air above a polluted source of water. In all three cases, the water produced is essentially distilled water. This is the subject of pending patent applications, US and international. You can see the information below. These are both assigned to Look for the Power LLC, of which I am the owner. For information, please contact me, John Saavedra, at john@lookforthepower.com or saavedra@mindspring.com. And the website is called lookforthepower.com. Thank you.